So first of all, I want to thank everybody for participating in this webinar. I know that it takes some time out of your busy schedules, but we've had some very positive feedback about this over the years. And you know, one of the things I do hear is that Howard really does give a lot of very technical information, and it's amazing as I go through the roster of people that participate in this webinar, I'll see the same person's name multiple times because, again, being so technical, they want to try to glean different pieces of information every time they watch it. So I definitely encourage any of you that are looking for that to definitely partake in the webinar again. That's what we have it here for. For those of you who don't know me, my name is Jason Spangler. I'm the division manager for flooring here at Wagner Meters. I'm responsible for not only the rapid RH and concrete moisture testing side of things, but I'm also responsible for our small line of hand meters for testing wood finished product and subfloors for insulation. We are going to be doing a Q&A session, so definitely if you have any questions, type them in and send them to me. Or if for whatever reason you think of something after the fact or even down the road, definitely take my information down and call me directly if you have any questions. My phone number is 800-634-9961 and it's extension 235. So without any further ado, one of the questions that I get a lot regarding the depth of the hole revolves around the question of slab thickness. And so there's a few things. One thing that I always tell people is that you'd be amazed if you're not really geared to look for how thick a slab is. It's amazing once you actually have your mind set that you have to figure that out, how many tells there are when you walk onto a job. So for instance, a rehab job or a renovation, there's a lot of times they might be moving plumbing, they might be doing trenching, they might be doing some other things like that, that with a slab on grade, you can actually see before they finish filling in the trench, you can see how thick the slab is, and you have a pretty good idea of what you have going on. Elevated slabs, a lot of times you have perforations or penetrations that come through the pan decking, if you will, and they usually make them much larger diameter than what the pipe is that's going through it. So you can usually see there what kind of situation you have as far as the pan decking and the thickness of the concrete. So, you know, I mean, those are some of the things that you can see visually. From an absolute standpoint, they do make a product that is what they call Echo Impact. It can be it's a device that can be hooked up to your iPad or Android device, and what it does is you put it on top of the concrete and it sends a signal down and gives you a very good approximation of overall what the thickness of the concrete is. Negative side of that, although it's very easy to use, it's also for most people out of the question when it comes to cost. Last time I heard it was about $2,000 for the device. So yes, very accurate, very costly, but it's an option. What I hear people telling me a lot of when they're out in the field or when they call me is that they'll typically take a smaller diameter drill bit and they'll drill a couple of strategic holes on the slab all the way through. Now, people bring up, well, what about penetrating the vapor retarder if there is one? So there's two things I say to that. One is, most people will say if that's the worst, you know, if you have a couple of holes on a 10, 15, 20,000 square foot slab within the vapor retarder, if that's the worst thing that happens to that vapor retarder, we've probably done very well. On the other side of it is when you drill concrete, you drill all the way through it, you'd be surprised at how you get to a point where you can, by feel, you can feel when you're about ready to go through the bottom of that slab. And so you can pull back on it and try to lessen the likelihood of penetrating that vapor retarder. So once they do those holes all the way through, they'll typically take a piece of wire, make like a J in it, push it all the way down through. When it comes out the bottom, they'll pull it up, take a Sharpie, mark it off, and then you have an approximation. And again, you're not trying to turn the slab into Swiss cheese by any stretch of the imagination, but you want to get a couple of different comparative pieces of information so that you can feel good about the decision that you're making as far as thickness of the slab, so you can calculate either your 40% or 20% of thickness, whatever that might be. Now, obviously, we're looking at slab on grade when I explained what I just explained. So the other question becomes, what about elevated slabs? And because with concrete that's poured into pan decking, you'll have varying thicknesses. You'll have a thick area, you'll have a shallow area. And so the question always becomes, do I calculate the 40% based off of the thick area, or 40% off of the shallower area? First of all, the ASTM standard is totally silent on this specific topic. So A, they don't talk about whether you're calculating based off of the thin or thick areas, but B, they also don't talk about whether or not the sensor should be placed in the thick or shallow area. So when I tell you what I'm going to tell you here, or explain what I'm explaining, is based on what I'm hearing from the field out there as far as the way people are actually processing these tests. A couple of different ways. One, I'm hearing people that will actually try to physically identify, without any kind of instrumentation, they'll try to physically identify where they're at. So they'll drill a couple of smaller pilot holes to try to identify where the high sections are at, and then they will try to place the sensor in the deep sections. So they will actually calculate their thickness based off of 40% of whatever the deepest section is, and then try to identify that. I have some people that will utilize, to do the same thing, they will actually utilize a fairly inexpensive metal detector that you can use much like a stud finder, a wood stud finder, and you can scan across the surface of the concrete, and the scan depth on it isn't so deep that it will go all the way to the bottom of the thickest section, but it's deep enough that it'll hit the what we call the hi-hats on the metal pan decking. So you can identify a high spot here, move it over, high spot here, and then drill in the middle of it and calculate based off of that thickness. Those tend to be the ways that are done out there. Hopefully soon in the near future, there will definitely be a little bit more absolute guidance on this. But at this point, that's what I hear is being done out in the field. Last thing I wanted to bring up was, it looks like I have a couple of architectural reps for one of our very large distributors. First of all, welcome. Second of all, I would say to anybody, especially the two of you, that we also have this webinar on demand with AIA credits associated with it for continuing education. And there's a website that's called AIAspec.com, and it's a tool that you can really use whether you're trying to use it with your customers if you're an architectural rep, or if you're actually trying to use it with your customers if you're a contractor and trying to explain the whole process of concrete moisture and possibly why there's issues that are going on. So definitely some tools that can be utilized. Take advantage of them. Again, AIAspec.com. So without any further questions, again, my name's Jason Spangler. If you have any questions for me specifically, don't hesitate to call me, 800-634-9961, extension 235. Thanks, and have a great day.